let's now discuss the risk assessment part of risk management, specifically for OT systems. As we said before, you don't do risk assessment once. You actually do it continuously, and you have to do it every time something significant changes in the organization. As example of such change would be the introduction for the first time on information security architecture. Maybe the company never had an explicit information security architecture, so you're going through the risk assessment process to properly develop it. Or it could be that given a new business objective, that you need to connect different information systems, so there will be information flow across systems that were designed separately. So you have to understand whether this information flow is introducing security risks. Then whenever you introduce new security solutions, an antivirus, a new firewall, some kind of social engineering mechanism for phishing emails, you have to reassess security, to do the risk management again, to understand how your risk is reduced given the security solutions that you have designed. Authorization, if you have new users, they need access to part of the system, their access is introducing new risks. So you have to refresh your risk assessment to understand how the authorization or the use of security controls are introducing new risks to the process. Modification of mission or business functions are also necessitate doing risk assessment again. It could be a new vulnerability discovered that affecting some of your products in your operational part of the network. So given that this is now a vulnerability without a patch is introduced, you have to redo risk assessment because now the impact of that risk is now different. Or it could be, for example, you do an acquisition of another company and you integrate it within your own system. Then you also have to understand how this changes the risks associated with that. And of course, the operation and maintenance of security solutions. You have to always see what are your current security solutions, antiviruses, firewalls, intrusion detection systems, ongoing authorization, who is updating what, who has access to what. You have to keep monitoring and maintaining that, and operational maintenance of these also necessitate frequent risk assessments. So let's start looking at how the risk assessment is being performed. Remember, we did first our risk framing, where we introduced our risk assumption constraints, tolerance that were first introduced, and then this will feed our risk assessment methodology. The methodology can be split into 4 different components that will be used: risk assessment process itself, the risk model you use for the assessment approach, and the analysis approach. So we'll do the risk assessment later. Let's see the individual components, starting with the risk model. Risk models define the risk factors to be assessed and how these things connect to each other. And we have some typical risk factors we already discussed: threats, vulnerabilities, likelihoods, and impact. And the risk model defines how these risk factors actually are connected to each other. An example of a generic risk model is seen on the slide. So we can think of there's an initial threat source with some characteristics, and the characteristic could be capability of the adversary, nation state or cyber criminal or insider, intent, do they intend to steal, to harm, and the threat source will initiate with some likelihood. Some nation states will be less likely to initiate that compared to a cyber criminal for ransomware, for example. So there's some likelihood of initiation to initiate a threat event. And the event will have specific actions, activities, or scenarios. The event, for this to materialize, the threat to become something impactful, it has to exploit, with some likelihood again, a vulnerability. A vulnerability could be a buffer overflow, or could be a hard-coded password, something that exists in our systems that can be exploited by the threat actor. Vulnerability will have some severity, and also it can differ given different predisposing conditions. Do we have a device with a buffer overflow problem connected to the internet or not? This is a different, even though the vulnerability exists, it has different predisposing conditions because it's different in risk if it's connected to the internet or not. Also, at the same time, we have some security controls either planned or implemented with some effectiveness. So if we have a proper firewall in front of the vulnerable device, then the risk is reduced compared to lack of firewall. So this is the step we understand vulnerability in the context of the conditions the vulnerability exists in and with assuming of the security controls. So the vulnerability, if exploited, will cause some impact. So we need to understand what that impact is. It can be just, could be information loss, or it can be damage to equipment, or it can be something as severe as human injury. And then the final risk in this generic risk model would be a combination of impact and likelihood of happening. Again, we need to understand if something is high risk and high likelihood, we need to definitely address it compared to something that's low risk, low impact and low likelihood. And this combination of impact and likelihood will be the organizational risk, and then we'll go back to framing, understand the risk tolerance, and respond to the risks that are above the risk tolerance threshold. So this is an example of risk model. That's a generic one, and one that has been used a lot, but the way that the threats, vulnerabilities, impacts, and likelihoods are connected can differ depending on the risk model chosen. So the other component of risk assessment will be the assessment approach. This is how you can assess a risk, because a risk can be assessed in different ways. One can be quantitatively, meaning you use numbers, like number one, risk 9, you can have a grade from 0 to 10, and you say, 10 is something bad, like high risk, 0 means very low risk or no risk. So using numbers can support properly cost-benefit analysis. That, for example, what happens if you respond to all the risks above 7, and you can get back what are the benefits you get from that. But then the problem is, what is 6, what is 5? Is 6 so much worse than 5? What about 3? Is 3 bad, or is 3 very, very something we shouldn't worry much about? So probably we need much interpretation, and whenever you try to convey that to decision makers, you tell them risk 5 and this risk 6, it's harder for them to make meaningful decisions. For that, you may want to approach this qualitatively. So instead of using numbers, you're using non-numerical categories. You say low, high, moderate, very high. So if someone hears low and high, they have a much better understanding of what this means compared to 4 and 5 or 4 and 6. So there you can easily communicate those risk results to decision makers to the high levels of the organization, so they can say, okay, we need to address all very high risks, or we'll create budgets for that, and then we address as many moderate risks as we can given the budget remaining. But then at the same time, you cannot really prioritize if you use non-numerical categories, right? If you have many high ones, how do you select one over the other? Also, you have different experts may say, this is, for me it's moderate, for the other one it's high. So different people may produce different results. So it makes prioritization difficult, and also makes comparison difficult. So to get the best of both worlds, you may choose to do the semi-quantitatively approach, that you use bins or scales, that the values and meanings are not maintained in other contexts, but within the context you can understand the severity of the risk. Example would be bins like, you have low, but the low is 0 to 20. So you can have your 10, 15, 5 within the low category, but you can also say this is just generically low. Still, you need a clear definition of bins with meaningful examples of what this means to properly communicate that to decision makers, while also maintaining appropriate relative comparisons of what is low, what is high, and how do we compare against each other. And the last component that we'll see is the analysis approach. So you can choose to assess risk from different approaches, actually. One can be threat-oriented. So you start by listing all the threat sources and you focus on the threat scenarios. And then vulnerabilities will be identified in the context of threats. So you say, my possible threats are a nation state attacking that part, a cyber criminal trying to steal information. So you focus on the threats and not on vulnerabilities or on other things. So you start, because you have to provide a list of risks, right, that to the decision makers. So the list is being created in a threat-oriented way. You go by threats, and then you provide the risk associated with every threat. Another approach would be to go after assets. So you start, you do some asset management, asset identification, inventory management, and you say, look, these are all my assets. I have these pieces of hardware, these pieces of software, and then I'm trying to understand per asset what can go wrong. So this asset can affect that part, this asset can affect that part. So instead of focusing on threats, you're focusing on assets to start your risk assessment. A third approach could be going after vulnerabilities. So assuming all the vulnerabilities that can exist given your predisposing conditions or exploitable weaknesses, you start vulnerabilities and then you go after the threats that can exploit the vulnerability. So you list vulnerabilities and then you do the threat analysis on the vulnerabilities to come up with the final measure of risk. As you can understand, the approaches are a bit different, and if you start with one, you may be missing things from the others. So starting from different parts, you may have bias in the results. So a proper approach would be to start with one, but also make sure you include the other. You can start with threat-oriented approach, but also ensure that all your possible vulnerabilities are included in your threat-oriented approach. Have a secondary orientation to improve the rigor of the analysis. So this concludes these three components. We saw a generic threat model, a risk model, an assessment approach you can take, medium, high, or numeric one, and an analysis approach. And now it's time to start looking at the exact process of risk management.